Now let's try to construct a Murray machine. So Murray machine is nothing but a deterministic machine in which output is associated with state, which means for every state we have only one output. Now we have to construct a Murray machine that takes set of all strings over a comma b, which means it is going to take all the strings which are possible over a comma b as input. So input alphabet is nothing but sigma equal to a comma b, that is what they have given, and prints 1. So output, they have to print 1 as output for every occurrence of AB as substring, which means whenever I see AB, I have to print a 1 as output. Okay, so output, let us say capital delta should contain 0 and 1. So output is 0 and 1, input is a comma b. Now the problem is this: whenever I give any string which is containing AB, it should print 1. If I give AB and AB, it should print 2 ones. If I see AB, BB, AB, it should print 2 ones here, that's it. And I don't care how many zeros it is going to print. For every AB, it is going to print 1. It is nothing but discounting number of ABs. So in order to construct this, we have to decide about 3 things. One is, we can design the deterministic finite machine for set of all strings starting with AB. See, we have to count number of ABs. For that, if I use the problem of starting with AB, the problem here is we are actually seeing only one AB and we are not seeing all the remaining ABs. If I say containing AB, it will be again starting with anything and then containing AB, which means we will be seeing only one AB, and after that we are not going to count. But if you take ending with AB, there we are going to actually count. Using that, we can actually count all ABs. Therefore, in order to solve this problem, I am going to construct a finite automata, or let us say a DFA, which accepts set of all strings ending with AB. Okay, so if you remember how to construct set of DFA for set of all strings ending with AB, this is how it looks like. I am not going to talk about the procedure, you already know it. Let us say ending with AB, initially I will be waiting for A and then any number of A's, that is not a problem. And if I see a I'll again wait for a B. If I see a B, I'll again wait for this. So this is actually DFA, which accepts set of all strings ending with AB, right? So if I see any number of B's, I'll be waiting for an A. So even if I get any number of A's here, it is still ending with A. So if I get a at the end, it means that entire sequence, a sequence has spoiled. I have seen AB and reached this. Let us say capital A, capital B, capital C are the states. Now I have reached C on seeing a AB. If I see a at C, I have to again wait for a B. Therefore, I'll go here and wait for a B. If I see a B at C, then I have to again see AB to reach it. Therefore, whenever I reach C, I'll reach C on seeing AB. See this? I'll reach C directly on seeing AB, or AB and again when I see one more AB, I'll reach it, or AB and again I can go back and again I can come. So whenever I see AB, I am actually reaching the state C. Therefore, according to the problem specification, if C is made to output 1, that can solve our problem, right? So whenever I see AB, I'll be in state C and it is going to output 1. And for the remaining states, you can simply give 0 as the input, right? So let us take an example and see this. Let us say the input is small a, small b. If I am in state capital A, if I see 0, I'll go to state capital B. And sorry, if I see A, I'll go to state capital B. If I am state capital B, if I see a small b, I'll go to state capital C. Now capital A is going to print 0, capital B is going to print 0, and capital C is going to print 1. Therefore, on seeing AB, I am able to print 1. If I see AB, AB, let's see what happens. I'll be in capital A. So capital A on seeing small a is going to capital B, and capital B on seeing small b is going to capital C, and capital C on seeing small a is going to capital B, and capital B on seeing small b is going to capital C. And now the output printed is, for A it is 0, output associated is 0, for B it is 0, for C it is 1, for B it is 0, for C it is 1. So which means for every occurrence of AB, I have printed 1, which is nothing but I have counted the number of occurrences of AB in a particular string. Okay, so this is the final answer.